Hey, I'm going to build a synthesizer, and it's going to be a journey. I hope that you can join me on it. It's going to be like a 3-year sort of mission here. In the first year, I'll do some designing and prototyping. In the second year, actually start some fabrication of the components, and at the end of the second year, have a complete unit that's all built. And in that third year, that's kind of the outreach and scale sort of phase. But right now, I'm starting from the beginning, the real basics. Like, this here is a transistor. It's a pretty cool component that, you adjust the voltage on the middle leg, and it controls how much current can flow from one side to the other. The transistor is really important in synthesizers like this one here. This is an Arp AXXE from the 1970s. I like it because it's almost like a textbook synthesizer. It's all solid state in there, and it has kind of one of everything. It has a voltage-controlled oscillator, LFO, a mixer, a VCA, and an envelope. And it has a little sample and hold and things like that. And it has a keyboard built in too. So to get from these solid-state components to sound, to music, one of the things we need to do is we need to turn a linear voltage into kind of an exponential amount of voltage. Because as you go up in the keys, you're increasing linearly in voltage because you have a simple voltage ladder across the keys. But the amount of current that you need to supply to the oscillator goes up exponentially because you need to double the frequency, double the pitch, and charge the capacitor twice as fast for every octave you go up. So a linear increase in voltage needs to somehow be an exponential change in current. And a cool thing about transistors is that they do that. They're not really designed for that purpose. It just kind of is the way it works. Usually you use them as switches. It's either on or off. So when you get these components, all of them are going to behave slightly differently. And so the first thing you need to do if you want to find ones that match, that behave the same way, is you need to have a matching circuit. And the Minimoog service manual has a couple of circuits that do just that. Why do we need to match? Well, these transistors, they change properties based on temperature and other things like that. But if you pair two of them together and have them fight against each other in just the right way, if they're matched, a lot of those other terms drop out so that you get a really clean exponential and repeatable behavior. But the first thing you need to do is you need to match them. So how do we do that? Well, let's take a closer look at this circuit here. So here's the transistor under test, but first let's kind of try to understand what's going on here. We have an op amp, and an op amp is actually a pretty simple device. It looks at the inputs on these plus and minus, and if this is greater than that, it puts out a high voltage. And here's one of those transistors that we were looking at. So the transistor is that little black package, but this is the way we draw it. This is a 2N309, which is the same type of transistor I was showing you. But they're all drawn the same, and the packages look the same too. Anyway, so when you put voltage in here, it adjusts the amount of current that can flow through here. And so what this circuit is doing is it's going to put whatever current is in here that's necessary to make this match that. Because if this voltage is too low, it's going to push more current in here, and it's going to draw more, push more voltage in here, and it's going to draw more current down this way until this opens up the gate a little bit more so that we can match these two. Okay, so this is going to drive this transistor to match whatever's on that plus pin. What's on that plus pin? Well, it's a voltage divider. We have two 10K resistors between ground and minus 10 volts. And so this is going to be a pretty solid minus 5 volts. And so we're going to be putting out not minus 5 here. We're driving this transistor until this one reaches minus 5. And so if we hold that at minus 5, right, then we get almost exactly 100 microamps going through that resistor right there. And so what we've built down here in this Minimoog service manual circuit is something that is a constant amount of current going through this resistor. Now, the op-amp doesn't let any current flow into it. The transistor doesn't let any current flow this way. The op-amp doesn't let any current flow in here. So it must get all pulled through this transistor under test. And so we ground the base and we pull current through it, and that forces the difference between these two pins here to be whatever is necessary to open up exactly that amount of current. And so we can swap out this transistor here with different things and hold this the same, and we can measure how much voltage drop corresponds to that amount of current. So I've built that circuit on this little proto board. I have to say, this is the first time I've ever done a proto board, and getting the components on there was pretty easy, but wiring up the back, I don't know if you can see that, wiring up the back was a real pain. But I'm learning. A lot of this is going to be about learning. So I've built both of those circuits on here. It's pretty simple to use. I want to also mention that this power supply. This is a super important tool to have when you're doing electronics, because this one is current limiting, right? So you can dial in an amount of current. I have it set at 15 milliamps because I know that's not going to burn anything out too badly. And we can adjust the voltage to be whatever we want. And so for this test circuit, 10 volts. I've got these two handles here for the positive and the negative rail. And then I generate a ground with this buffer chip here and a little voltage divider. And then the actual test circuit is this half over here. So we have the power connected up the sides. I have little probe points for my probe. Of course, it's super important to have a multimeter to measure accurately. Right now we're measuring 0.558 volts across this transistor. And watch this, if I touch it, it drops 5.7, 5.6, wow, all the way down to 5.47, 5.46 millivolts, still going down, 5.43. So just that little bit of heat from my fingers makes a pretty big difference. And so that's part of why we need to match these things. So the next thing to do here is probably find some matched transistors and build that circuit that just exponentiates the current, exponentiates the voltage, so that we can have a current that's proportional to the exponential of the voltage. And that will feed into the oscillator, the first part of the synthesizer. Wow, there is a lot to go. But this is going to be a great journey, and I hope you join me on it. So please leave comments below. Let me know what you think. I'm going to read them all. I hope you join me.